Hi guys, Mark here, and today we're looking at day 21 of the Advent of Code challenge. And this was a fun little problem today. Basically, we've got a computer game and you're having a battle with the boss, and whether you win or not depends on how good your weapon is and how good your armor is. And before you go into the battle, you can go to the shop and you can buy a better weapon, better armor and some rings which improve the strength of your weapon and armor. And the question is quite simply, how much do you need to spend to guarantee that you'll beat the boss? What's the minimum amount you can spend in the shop? And all the input to our problem was, well, it was really the inventory of the store plus details of the boss, how many hit points the boss has, how much damage the boss's weapon can do, and how much armor the boss has. And so it really wasn't about parsing text files today. It was about just coming up with the algorithm. And really there were two main parts. Let's have a quick look at some C# code first. There were two main parts to this. One was get all of the different options of what could be bought from the shop, and secondly, implement the battle algorithm to see who wins the battle. And it may sound like that getting all the options of what could be bought from the shop will be a ridiculous number of permutations, but actually it's not that bad. You have to buy one weapon out of 6, you can only buy one piece of armor out of 6, and you can buy up to 2 rings out of 6 available rings. So actually enumerating through all the options wasn't that hard. And this problem, I think, lends itself more to kind of an object-oriented approach where we come up with some classes. So I designed a couple of classes for a shop item. What's it called? What's it cost? How much damage points it has? How many armor points it gives you? And then I could just create some instances of that for all the things in the shop. And also I had a class called player status, which has how many hit points the player has got left, how much damage and armor they could have. I also tracked how much gold had been spent at the shop, and even kept track of what was in their inventory, what things they'd bought, which was just useful for debugging purposes. And so let's have a look at the first part of the problem where we're going to get all of the options. And you could go for a real brute force approach where you kind of just get every combination of things that could be bought from the shop and filter out the ones that aren't valid, but that would be ridiculous. Really, we just need to go through all the weapons, pick a weapon, and then go through all the armory and pick 0 or 1 items of armor, and then we power up with some rings. So I basically made a function that returns an IEnumerable of player status, returns basically all of the starting statuses that the player could have, which will have 100 hit points, and then depending on what they bought from the shop, we'll track how much damage they can do with their weapon, how much armor they have, and how much gold they spent. And I made a second level of function called add rings, so that for every of the weapon plus armor options I can add 1 or more rings to it, or 0 or more rings to it. And I even put a couple of helper methods on my player status class, one of which is called power up with. So if we just look at the definition of that, and I went for a kind of almost immutable style here. So when you power up a player with a shop item, you actually create a new player status, which has the same number of hit points but adds on the damage and armor amounts and gold spent of that shop item. And this basically is necessary because when we're generating the series of possible starting states, we don't want to overwrite the values of a previous starting state we've created. And so let me just show you first of all what happens when we call get player options. You can see all the possible starting states. So you've just bought a dagger and nothing else, so you spent 8 gold and you can do 4 damage but you've got no armor. Or you've bought, if we scroll down a little bit, here you've bought a dagger, leather, the +3 defense ring, the +1 damage ring, and now you've spent 126 and you've got 5 damage and 4 armor. And so as you can see, this is nice and quick to generate all the possible starting states. Now we need to make sure that we can actually fight the battles. And I've got a battle function, so let's have a quick look at that. And I actually simulate the battle. So while both the players are still alive, we take hit points off the boss because the player gets to strike first, and then the boss hits back if he's still alive, and we keep going until one of the players is dead, and we return true if the player has won or false if the boss has won. And again, not a hard algorithm to write. You actually don't need to use a while loop. You can calculate this in one, but one of the interesting things about the advent of code challenge is that you know that a part B is coming up, so it forces you to try to anticipate what future requirements might be coming your way, a bit like in regular programming as a job. You're not just writing code that meets today's requirements, but you are trying to anticipate what future requirements might come, and can I write my code in a way that will be flexible no matter what the next thing the customer asks for is. So I left this as a loop. And I wanted to show you this implementation because although getPlayerOptions, when it was called on its own, worked perfectly, and the battle function, you can see I've made a few test battles, also work perfectly, when I put them together, and I'll give you a clue here because I'm going to comment a little bit out. When I put them together and I just got the first 100 options, and then I said all of the options of what the players bought from the shop, where they win the battle, order that by the gold spent and take the first one, and that's going to give us our answer. And when we ran that, I found that we never won the battle, and it confused me for a little while. What was going on? Why did we never win the battle? And of course, the problem was my players weren't truly immutable. You see, it doesn't first of all get all the players and then see if they can win the battle. And you can see here I was creating a new boss object every time because I was aware that there might be a potential problem if I reuse the same boss object, because if he died in the first one, then his health would be still at 0 and he'd lose every subsequent battle. But why is this happening for the players? Because the getPlayerOptions is returning many different player classes. It's not returning just one player class. And the reason is, of course, that when we make a link chain like this, all of the players aren't generated up front. They're generated one by one. And what I was actually doing, the mistake I made, is in Power Up With, the new player status that I create gets a copy of the hit points of the player that was previously created. And the trouble is, that player has just fought a battle, so hit points isn't 100 anymore, it's dropped down. And so what I needed to do was either first turn all the options to a list, so that would mean that they all definitely had hit points of 100, and that works fine, or I should really use immutable objects. And so on realizing that bug, I did switch to truly immutable objects, so that if we go to player status, using this C#6 syntax where there is no setter at all for these methods, that means they can only be set in the constructor, even the hit points can't change. And so I had to add a method called hitBy, and it returns a new player status with the change to hit points. And so if we go to the battle function, every time the player is hit, we must now reference the new boss that's been hit and the new player that's been hit, because it's a new object. We don't hang on to the objects that have been passed into the function. And actually, I think this is probably a good advert for the benefits of coding in an immutable style. You can come into really weird bugs and hard to reason about code when your objects can change their state after being created. It's one of the reasons why functional programming is on the rise. But apart from that, I know this isn't particularly concise code, but the way I wrote it, part B wasn't actually as hard as I thought it might be. Basically, we just have to flip the condition. We're looking for the battle where we lose where we've spent the most gold. And so that was quite easy to do in this immutable style because I only needed to get my options once. In the non-immutable style, to do part B, I actually had to get all the player options again, because once again, every player in the options list had now fought one battle, and so their hit points had dropped. So let's have a quick jump over to F#. Obviously, in a functional programming language, we're going to be working with immutable objects, so this bug is not going to hit us. And I was also able to make use of, in F#, it's got a very nice succinct syntax to create record types. So my shop item and my player are record types. You just basically say what the properties in their type is, and you've got an immutable object ready made for you. And it also makes it much easier to create a new immutable object based on a previous one by using the with keyword. So I can say, if I want to make a new player, I can base it on all the properties of an old player, but just changing one of the properties. So the same as the previous player, but with the hit points been changed. And so here I've got lists of all the things that are in the shop. The two methods to work out all the things we could buy probably could be optimized a little bit, although the yield bang operator in F# does make this a bit easier than C#, because I can say just yield all of the options with 1 or 2 extra rings based on this initial option. But other than that, this really is the same as the C# version. And then the battle function, again, this could probably be made a lot more succinct, but I made a recursive battle function, so we don't have to have any mutable state, and we're past a boss and a player, and the player hits the boss to start with, and that creates a new boss object, and then the boss hits the player, and that creates a new player object. So we've got to just remember that we're checking the new objects, not the old ones, because they're immutable. Their hit points are never going to go down. But then, having done that, all we need to do now is get all the options of things we bought from the shop, filter out the ones where we won the battle, and then pass it into seek.minBuy to get the minimum amount of gold spent to defeat the boss. And for part B, it's almost exactly the same. The minBuy turns into a maxBuy. F#'s not operator is a little bit cumbersome, I think, but we just have to compose the battle against the boss function with not to essentially reverse the condition for this filter, and that gets us part B. So again, not really gone for conciseness here. I know you could have done away with using records and just used arrays of integers and made the whole thing a lot more concise, but actually I think sometimes it is good to write code in the way that you would do in a real world game, where you would have classes or record types for things like players and shop items. Anyway, thanks for watching, and hopefully I will see you for tomorrow.